All right, let's talk about metallic bonds. First, you need to know that metals form a lattice structure. So it's similar to ionic bonds, like we talked about earlier, where you've got one atom, one metal atom is surrounded 8 to 10 other metal atoms. Okay, and then they basically kind of form this three-dimensional structure to where it's very strong. Uh, so there's a couple of different concepts that we're going to deal with. The first concept is the electron C model. Okay? And this is I wouldn't say it's a theory, but it's the idea that um, all the metal atoms in a metallic solid contribute their valence electrons to a collective group of electrons. So all the metal atoms. Okay, so basically all that means is you have your metal cations, and those valence electrons that are associated with those kind of go into a community pool or a community sea of electrons, and they just uh, kind of flow around all of them. There's no set cation that the electrons are a part of. So what you have is all of these metal cations forming this structure. Okay, let me put a couple more in here. All right, so you have these metal cations that have come together, and then interspersed through all of them, and in no real particular order, are all the valence electrons that have kind of apart from their metal cations, and they're just kind of flowing around. Okay, this electron right here does not belong to that cation. It can move all the way over here. It can move inside here. It doesn't really matter where they are. Okay, so that's the electron C model, and what it does is it kind of hinges on the idea of delocalized electrons. Okay, so delocalized electrons are just electrons that are free to move from one atom to the next. They're not held in any outer energy levels of any specific metal atom. Okay, so again, all the electrons here, that one, that one, that one, that one, that one, that one, those are all delocalized electrons. Okay, they are free to move about wherever they want in that entire model. Okay, so the electron C model is here, and then the delocalized electrons are a contributor to the electron C model. Okay, and the delocalized electrons are what make what make the electrons special, I guess, is that they're all shared. Okay, so all electrons, all valence electrons, I should say, all valence electrons are shared, and that's what makes them special in a metallic bond. Okay, so all valence electrons are shared. Okay, just in general, a metallic bond is basically the attraction of a metallic cation to a delocalized electron. Okay, so those are what metallic bonds are. So let's talk about some properties of metallic bonds and properties of metals. We're going to kind of go quickly through these because, again, they're just definitions. So, and then boiling points are generally very high. Okay, so obviously you're dealing with metals, and you've heated up a metal before, and it tends to be pretty hot before it actually melts. These are malleable. Okay, which if you don't know what malleable is, that means it can be hammered into sheets. Okay, so aluminum foil is just aluminum that's been hammered into a sheet. Okay, so aluminum is malleable. Metals are malleable. They're able to be formed into different things. These are ductile also. Okay, and ductile just means that it can be formed into a wire. Okay, so like copper can be heated up and pushed through a circle to where it forms a wire. And then last one, not last one, but another one is they're durable. Okay, the electrons that are associated with them are not easily removed. Okay. They're also really good conductors of electricity and heat while we use them in cooking. Also lustrous, which means they're shiny. Okay. So last one here, stronger metallic bonds are formed in transition metals. And that is basically due to an increased number of delocalized electrons. Okay, last thing is metal alloys. All right, and then just an alloy in general. General definition is a mixture of elements that has metallic properties. Two types. You have substitutional alloys. Okay, and substitutional alloys is when some of the atoms in the original metallic solid are replaced by other metals. So are replaced in the solid with other metals. Here is other metals of similar size. Okay, and the second type is interstitial. Interstitial alloys are formed when the small holes in a metallic crystal are filled by small atoms. So small holes present in crystal. Okay, and that's just the three-dimensional form of it. So when those small holes are filled by smaller atoms. Okay, and what that does is it just makes it more dense and a little bit stronger. Okay, so that's metallic bonding. As long as you know the properties and the definitions, you'll be just fine.